Now let's see the last case in the partial fractions, in which in the denominator we may have some non-factorizable quadratic factor apart from the linear factors. So if that is the case, that is as shown in this example, suppose we have this particular type of function to be broken into the partial fractions, then on the right hand side we write the first fraction as normal, that is a upon x plus a, which we have already seen, plus now since the second factor, which is lx square plus mx plus n, is not factorizable, right? So in that case we must write the entire factor as it is, but the only difference is that while writing its numerator we will not write it as just b, but we will write bx plus c. That is, the numerator must be an expression which is having the degree just one less than the degree of the denominator. So since denominator is a quadratic factor, we must have some linear expression in its corresponding numerator. Of course, it may happen that we may realize or we may find that b is equal to 0, which is fine, but in general we must consider bx plus c as the numerator in general. Okay, and rest of the procedure is same. We cross multiply and substitute the convenient values to get the constants a and b. Okay, so let's see one example of this particular type. Alright, now here we are given 2x plus 3 upon x minus 1 into x square plus 1. So let's first of all call 2x plus 3 upon x square plus 1 as first factor is linear and non-repeated, so we write a upon x minus 1, plus for the second factor we write bx plus c whole upon x square plus 1, because you see x square plus 1 is not factorizable because it will give us the imaginary roots and we must consider the real roots here, right? So this gives us, on left hand side the numerator is 2x plus 3, and on the right hand side the cross multiplication will give us the numerator as a into x square plus 1 plus bx plus c into x minus 1. Right? Now we observe that if we put x as x as 1, then the entire second factor will vanish, isn't it? So that will readily give us the value of capital A. So therefore let's first put x as equal to 1. So on left hand side we have 2 into 1, that is 2 plus 3, that is 5, is equal to a into 1 square plus 1, that is 1 plus 1, which is nothing but 2. So that gives us a as nothing but equal to 5 by 2. We got the first constant, right? So we have got a. Now what we can do is, let us put x as 0, so that since x is attached with b, the term in b will vanish and we can get c, since we already know what is a. So by putting x as 0, the left hand side is 3, right? On the right hand side we have 0 plus 1, that is 1, and a is nothing but 5 by 2. So we have 5 by 2 plus c into x minus 1 is 0 minus 1, so that is minus 1. So therefore that is minus c. So bringing c on left hand side, we have c as nothing but 5 by 2 minus 3. So that gives us minus 1 by 2. So that is the value of c. And now as we have seen, to get b we can put any other value which we want. So let's put minus 1 because that is easy from calculation point of view. So on left hand side we have minus 2 plus 3, that is 1, is equal to, now minus 1 square plus 1, that is 2a. So a is 5 by 2, so 2a is obviously nothing but just 5, isn't it? Plus, now into bracket we have bx, so that gives us minus b, and plus c means minus half, into x minus 1, that is minus 1 minus 1, that is minus 2. Alright, so therefore that gives us now 1 minus 5 is minus 4. If we multiply the two brackets, we get minus b into minus 2, so that is 2b, and minus 1 into minus 2 is plus 1. So therefore that gives us 2b is equal to minus 5, and therefore b is nothing but minus 5 by 2. So in this way we have got all the values of the unknown constants. So now based on this, let us substitute and get the final answer. So our integral can be written as integral of a is 5 by 2, so that is 5 by 2 upon x minus 1. Plus, now here we have bx plus c, so that is b is minus 5 by 2, so here we have minus 5x by 2 plus c, but c is minus half, so we have to write it as minus 1 by 2 whole upon x square plus 1. Now to solve this, the first integral is straightforward, that will be nothing but 5 by 2 into, now integral of 1 upon x minus 1 is nothing but log of x minus 1. So here we have a log of x minus 1. Now from the second term we can take minus sign common, and let us take even 5 by 2 as common term. So we will be left out with x upon x square plus 1 . One sec. Alright, so here we have x upon x square plus 1. And from the second term we have minus 1 by 2, that can be taken common, and we have the integral of 1 upon x square plus 1. Now this last integral, as we can see, it is easy to calculate because that's a standard result, which is tan inverse of x. Now just in the second integral, if you observe, we have denominator as x square and the numerator is x. So the derivative of denominator, which is 2x, can be easily adjusted in the numerator by multiplying and dividing by 2. So the answer of that will be log of x square plus 1. So in this way we can evaluate all the integrals, okay, and that is the final answer.